All right, class. This is the assignment for day 32, force. It's your introductory lesson on force, assigned on Thursday, March the 12th, 2020. And we're going to do this in class because I want you to know how to do this in case the school closes down and we have to do some distance learning. So we're going to do this entire assignment in class via video. So Jose pushes, number one, Jose pushes a 150 kilogram cart with 25 newtons of force. At what rate did the cart accelerate? Okay, so the question is asking for acceleration. A equals question mark. We have kilograms. 150 kilogram cart. So what does that mean? If you're not sure, come over here to the common units of measure. Go down and find kilograms. There it is right there. And you come across and you see that that's a measure of mass, M. So we can go ahead and write that down. And 25 newtons of force. Well, it tells you that it's force. 25 newtons is a force. So F equals 25N. Okay. And so what we have is A, M, and F. So you come down and you look on your chart. You just start at the top and work your way down until you find a formula with those three. And there it is right there. F equals MA. So we're going to go ahead and write that formula. And then we have to ask ourselves, do we have to do algebra on it? Well, it's not solved for A, it's solved for F, and we need it to be solved for A, so we come over here and do the algebra. Divide both sides by M. Cancel, and you have A equals F over M. It's your formula, so you come back. You don't need to rewrite the formula, but go ahead and plug in the numbers. F is 25. M is 150, and when you do that on a calculator, you're going to get the following 0.1666, which I'm going to round to 0.17, and that's meters per second squared. Okay, so that's your final answer for that. All right, 2 is exactly the same as 1, except I changed the person's name. Didn't change anything else, so we're going to skip that. We'll go down to number 3. Carlos accelerates a 5,000 Newton truck at a rate of 20 meters per second. What is the mass of the truck? So this one's asking us for mass. M equals question mark. Again, if you don't know that, you come down here. Now that's a variable. Mass is a variable. There it is. Mass. Okay, M equals question mark is what we're trying to find. It says it's a 5,000 N truck. So it doesn't say what 5,000 N is in this case. So if you're not sure, again, you come down units of measure. The letter comes after the number, so that means it's a unit of measure. And there's N, newtons. And that is a measure of force, F. So learn how to read the yellow sheet, and the class will be very easy for you. 5,000 N. And 20 meters per second squared. So maybe you forgot what meters per second squared is. Come down units of measure. There's meters per second, meters per second, meters per second. There we go. Meters per second squared is right there. Now it could be either of these two, but those are both forms of acceleration. We're not dealing with angular acceleration though. We're just dealing with straight acceleration. Angular acceleration is something going in a circle. There's nothing in this problem to indicate that it's doing that. So we are going to say acceleration equals 20 meters per second squared. Again, we have the same three variables as in problem 1, so we're going to find the same formula as F equals MA. Again, though, we have to do algebra because we're looking for M and it's not solved for M. So we come over here, rewrite the formula, divide by A both sides, and we have M equals F over A. So we come back and we write M equals force, 5,000 newtons, over 20 meters per second squared. And if I divide that in, I get 250. And I'm running out of space here, so I'm going to put it over here. So the final answer is M equals 250 kilograms, because that's the unit of measure of mass. Again, if you weren't sure of that, you just come over here, find mass right there, and say, okay, that's measured in kilograms. All right, so there is your final answer right there. Okay, let's move on down to problem 5. Okay, Brian has a mass of 50 kilograms. What is Brian's weight in newtons? So it's a formula we didn't formally introduce you to, but it's on the sheet. And if you learn how to use the sheet, you can go find these things. Weight is a force. It's measured in newtons. And it's simply a special application of F equals ma. Weight is a force. It's the force of gravity. Mass is mass, same as F equals ma. And g is gravitational acceleration. So that takes the place of a. So this really is just a special case of F equals ma right here. So we have weight equals mass times gravitational acceleration. So what is Brian's weight? W equals question mark. His mass is 50 kilograms. And since we're dealing with weight, rather than use A, we'll use G, and that equals 10 meters per second squared. That's gravitational acceleration. We've used this number in class before. If you didn't know that or remembered, it's down here at the bottom of the page. G equals that, and as it says here, we usually use 10 meters per second squared in class right there, okay? When we do a lab or a project, we try to use the accurate figure of 9.8, but for this, we'll just use 10. So we have W equals mg is the formula that we get off the sheet. It's solved for the variable we're looking for, so there's no algebra. So we just write W equals 50 times 10. And we end up with W equals 500 newtons is the weight. All right, the next one is, let's see. Didn't really give you a conversion between newtons and pounds. Well, we did. It gave you a conversion between newtons. I'm sorry. So gives you a conversion between newtons and pounds. And then you know the number of newtons. So what is his weight in pounds? So we have 500 newtons. And while we haven't practiced this skill yet, and we will, let me just show you how to do it, how you set this up. 500 newtons. Now you're making a conversion to pounds. So when you have 1 pound equals 4.5 newtons, you can write that one of two ways. That there's 1 pound for every 4.5 newtons, or there's 4.5 newtons for every 1 pound. Those are both true statements. There's 1 pound for every 4.5 newtons, or there's 4.5 newtons for every 1 pound. Both true statements. But which one do we want? We want the one that's going to make newtons cancel out and pounds appear in the final answer. So we want LBS, pounds, to appear over here. And we want to put something in the box here, one of these two ratios, to make it N cancel out and pounds appear on the top. So the one that does that is the first one. Even though these are both true, this is the one we want to use. So we write 1 LBS over 4.5 newtons. So newtons cancels. So now what we do is we divide 500 by 4.5. And we get 111.1 pounds. Okay, so that's your final answer right there. This is called dimensional analysis, where you set up your units to cancel out so that you end up, the unit that's left standing at the end is the one that you want your answer to be in. We'll talk about that more, but at least you got to see an example of it right there. Okay, we're going to move on. And now we're on to the advanced and super advanced problems. And it turns out that 6 and 7 are identical. They're not identical, actually. So we're going to do 6, 7, 8, and 9. Yeah, they're not identical. So here we go. So these are going to require 2 formulas and possibly 2 formulas and algebra. Okay, so here we go. Nicole is riding a 10-kilogram bike at 5 meters per second when she accelerates to a final velocity of 7 meters per second in 3 seconds. How much force did she use? So you're trying to find force, F equals question mark. And now identify the numbers here. You're given 4 numbers to deal with. 10 kilograms. Go to your gold sheet, find kilograms. There it is right there. Come over here, it's a measure of mass. So mass equals 10 kilograms. Now it gives you two velocities. Let's just write them down first. It gives you a 5 meter per second and a 17 meter per second. And then finally it gives you 3s right there, which is time. So we will determine what the velocities are. So she's riding at 5 meters per second and she accelerates to a final velocity of 17. So the final velocity is this. This is VF. And this has got to be VO. That's her velocity at the beginning of the problem. It can't be the velocity all the way through the problem because she ends up going 17. So it's the velocity at the beginning of the problem. So that's VO. All right, so now we need to find force. We have a formula for that, F equals MA. Okay, so we look, we need M and A. Do we have M? Yes, we have M right there. Do we have A? No. But do we have enough information to figure it out? And the answer is yes, right there. I think you can all see that's going to be this formula. And that's going to equal 4 meters per second squared for acceleration. We come back over here, F equals M, which is 10, and A, which is 4. We multiply those, we get 40. And since it's a measure of force, we just come over to our sheet and we see that force is measured in newtons. Okay, so there you go. All right, next up. Next up is almost identical, but it's not exactly the same numbers. So this number is different. So let's go ahead, and this number is different. So let's go ahead and work it. How much force did she use? Again, it's asking for force. Actually, I'm going to let you do that one since it is identical to the one above. It's just two numbers have changed, and that's the idea that you do this one. You saw me do this one. Now you do that one. Okay? All right, next up. Nicole begins, number 8, Nicole begins pushing a 50 kilogram cart from a position of rest with a force of 250 newtons for 4 seconds. What was the final velocity of the cart? Okay. So this is going to take some algebra because there's no formula for final velocity, so we're going to have to do some algebra on one of the other formulas. So that's going to be a question mark. Okay, it's a 50 kilogram cart, so hopefully by now you recognize that that's mass. Okay, from a position of rest, we've come to learn that that means that the initial velocity is 0 meters per second. When it's when it's at rest, it's standing still. So it's standing still. That means it has no velocity. And we have a force of 250 newtons. And we have a time of 4 seconds. Okay, so for VF, well, there's a couple formulas we could use. You could try V equals VO plus VF over 2. But I can see that since I got mass and force, that acceleration is going to play into this somehow. So I'm going to assume that the formula I need to use is this one to find VF. A equals VF minus VO over T. So I know I'm trying to find VF. I know VO right there, and I know T right there. But I don't know acceleration. So can I find acceleration? Well, I have another formula, F equals MA. And I know M, and I know F. So if you know these two, you could find acceleration. If you know acceleration, you plug it in over here, and you know that, you'll know that, you'll know that, so you can figure out VF. Both are going to require some algebra here, okay? So I'm going to violate my rule a little bit, and I'm going to do the algebra right here. So F equals MA, and I need to figure out A, so I divide by M, and I get A equals F over M. Now I'm going to plug in the numbers right there, 250 over 50 equals 5 meters per second squared. So that's the acceleration. So now I need to solve this equation for VF because I'm trying to find VF right there. So we'll come over here and do the algebra. A equals VF minus VO over T. We're going to multiply both sides by T, and we end up with AT equals VF minus VO. We're going to add VO to both sides, cancel, and we end up, a little crowded down here, but we end up with VF equals AT plus VO right there. Okay, that's our formula. So that now we come back and we can solve. We have VF equals A. There's A right there. We just figured it out a moment ago. 5. T is 4 seconds. Plus VO, and VO is 0. So VF, therefore, is 20. And since it's a velocity, it's measured in meters per second. Okay? So that one was about as challenging a problem as I could give you. There were 2 formulas, and both of them required algebra. Okay, that's a super duper advanced problem. Okay, let's go to the last one now. And this is exactly the same as 8. So I'm going to ask you to follow this example. You're going to use the same formulas, the same algebra, but you want to see if you can do it without looking at this one. Okay, so let me go over this one more time then. So I needed to find a formula for VF. Since I have mass and force, that figures acceleration is going to come into it. So I'm going to use the acceleration formula, which has VF. Okay, so I need to find A. I know VO, I know T. I'm trying to find this, and I need to find A. So I use F equals MA. I know mass and I know force. So do a little algebra, you figure out acceleration. Now we come back over here, we know acceleration, we know VO, we know T, but we got to find VF. To do that, you got to do the algebra on this to get to VF. There it is. And eventually you get VF equals this formula. You come back here, and there's your final answer. So I'm going to ask you to do that one on your own. And so 7 and 9 are your kind of your challenge problems, but they're done exactly the same as 6 and 8. All right, so that's the video as we're going to do it. I'm going to this assignment is due on Monday, I believe. Let's check that out. It is due on Monday, March 16th, but we're going to try to finish it up in class today on Friday. All right, so you have a good day, and this will be a sample of the kind of lessons that we'll be doing in the future if school is called off. Have a good day.